Okay, this lesson is term 3, lesson 3 about theorems and lines and angles. Okay, what we have here is we've got a diagram of two horizontal lines with a diagonal line. So we're going to call this a transversal. Transversal means it travels across these two horizontal lines. So what do we notice about the angles? Well, I'm kind of looking at this diagram. Let's look at 1, 2, 3, and 4. It looks like number 1 is an acute angle, number 4 is an acute angle, and it looks like they're the same measurement, And number 2, we got angle 2 here. It looks like it's obtuse. Also with angle 3, looks like it's obtuse. So for me, they look like they're the same measurement. So what I have here is two lines that when the transversal intersects this horizontal line, it creates congruent angles. Let's look down here. Number 5 is an acute angle. 8 is an acute angle. 7's an obtuse, 6 is an obtuse. So it looks like 5 and 8 are congruent, and 6 and 7 are also congruent. Okay, there is a theorem when you have two parallel lines whose slope is identical, which would be these two horizontal lines right here, okay? And when they are cut by a transversal, it creates congruent angles. So transversal is a line that cuts through another line. When a transversal cuts through a set of parallel lines, we can learn some things about the angles. Okay, and that's kind of what we identified. It looked like 1 and 4 were congruent, 2 and 3 were congruent, 5 and 8 were congruent, 6 and 7 were congruent also. Okay, so let's talk about what acute means, okay? If you can't remember what acute means it's an angle less than 90 degrees. Okay, obtuse is an angle bigger or larger, however you want to put that, bigger than 90 degrees. Okay, a right is an angle. We talked about right triangles when we worked with trigonometry, and a right angle is exactly 90 degrees. Okay, complementary are two angles that add up to be, let's call this number 2, that add up to be 90 degrees. Supplementary are two angles that add up to be 180 degrees. Okay? All right. Okay, draw this picture in your notes and label the angles as follows. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're going to use it to talk about relationships amongst angles. Okay? So, number 1 and number 4, angle 1 and angle 4, we call those vertical angles. Okay? Could we find another pair of vertical angles? How about angle number 5 and angle number 8? How about that? Okay. Another set would be 2. I'm just going to put 2 marks here. 2 and 3 because they're equal measurement. How about angle 6 and also angle what? 7 there. So angle 6 and angle 7 are also vertical angles. Okay? All right. Okay, now angle 1 and 5, okay, they're on the same side of the transversal. So I'm looking at angle 5 here, or let's look at these angles here. Angle 1, it says angle 1 and angle 5 are corresponding. The prefix cos means with. So we'll say with the same side. So they are on the same side of the transversal, and they also have the same measurement. Okay? 4 and 8 are corresponding angles. I'm going to put this here. 4 and 8 are also corresponding angles that are congruent. Are corresponding angles the same or different? They are the same. Okay. All right. Okay, let's go to the next slide. Okay, 3 and 6, we call those alternate interior. Notice the word interior means inside the parallel lines. So let's look at 3. 3 is an obtuse. Guess what? 6 is an obtuse. They're inside the parallel lines, but they alternate across the transversal. And then we've got 4 and 5 are also alternate interior. So are alternate interior angles the same? Yes, they are the same. They are the same measurement. Okay, 1 and 8. Okay, let's talk about 1 and 8. Okay, now these are called alternates. So it means one's going to be on one side of the transversal line, this line right here, and exterior means on the outside of the parallel lines. So we're looking at 1 and 8. These are alternate exterior angles. Also on the outside, we've got 2, and we've got number 7 down here. They're also congruent, and which means they are equal on the angles. So those are alternate exterior. Okay, consecutive interior. Okay, so let's look at this consecutive. There's that little prefix, co, which means with. So we're going to say with the same side. That's how I'm going to think of it. With the same side. So let's look at 3. Now look at this one. This is an obtuse. This one is a acute angle. So are consecutive angles the same? No, they are different. But 4 and 6, so 4 and 6 are on the same side, the transversal. They're consecutive. Now, an interesting note to put here is you could put angle 3 plus angle 5 equals 180 degrees. You could also write angle 4 plus angle 6 equals 180 degrees. That is what consecutive interior angles do. All right. Okay, next one we have linear pair. A linear pair are two angles that share a side and form a line. Since there is 180 degrees in a line, these two angles are supplementary. So we have angle Q right here, QSR. This is an acute angle, okay, less than 90. Then we've got angle PSQ. So these two angles, so let's write this out. Angle PSQ plus angle QSR equals 180. Okay, this is a straight line. Okay, those two angles form 180 degrees. Think of this as like the sun at the horizon. We see it as it creeps down below, but we see at least half of it. The other half would be somewhere down here. So this would be a full circle. My circle's not very good, but you've got the idea. So we're seeing half of it. So this is 180 degrees. The other piece is 180, which is 360. That's sometimes how I think of a straight line. Okay, now let's think about this. Would angle 1 and angle 3 also add up to be 180? Yes, they would, because we've got an acute angle here. Right here's our acute angle, less than 90. And then we've got an obtuse angle here, which is more than 90. So these two would add up to be 180. Another combination might be 3 and 4. That's going to be 180. 3 plus angle 4, that would be 180. Also, angle 2 plus angle 4 would also be 180. And also, angle 1 plus angle 2 is also 180. So we have lots of different options on this particular diagram right here. Okay, let's look at this. Okay, now, we've got these relationships here. We've talked about corresponding right here. We've talked about corresponding angles right here. We've talked about alternate interior, alternate exterior. We've talked about consecutive angles. So make sure that you've got those written down so that you understand the vocabulary as when we're discussing different angles and where they're located. Okay, given line L is parallel. So let's look at this right here. This is given. Okay, they want us to do some type of a proof here and give a reason. Okay, all right, so we're looking at it and they're saying, all right, okay, you've got this information. Okay, so they're saying angle L, or excuse me, line L and line M, let's put an M here, are parallel. This little symbol here, guys, right here, means parallel. Parallel. So there we go. And it says, and what you know about angles thus far to prove that angle 3 and angle 5 add up to be 180. So in this, when you're doing a proof in a given right here, and there's different ways you can do this. Given, they told us that line L is parallel to, I'm just going to do a little L here, is parallel to line what? M. That's in the given. Okay, let's give some reasons we think that 3 and 5 are going to add up to be 180. Okay, how about if we say angle 1 is congruent. Let's see, angle 1 is equal to angle 4 because they are vertical angles. And they're equal. Okay, how about if we say angle 2 is equal to angle 4? No, angle 2 is equal to, let's change this to angle 3. Let's get this back here. We'll change this to 3 because of vertical angles. And there could be different ways of doing this. I'm just going to kind of do it this way. All right. Okay, now, and they are angle 1 and angle 4. Let's put these are acute angles. And these are obtuse angles. All right. Okay, now we can say angle 5 is equal to angle A because of vertical angles. They're acute. And then we could say angle 1 let's see here. I know, I'm probably doing this the longhand way, guys. Angle 6 is equal to angle 7, vertical angles. They're obtuse. Okay, then we can say angle 1 equals angle 5 because they are corresponding angles. They're on the same side of the transversal. Angle 3, corresponding angles, and they are acute. We could say angle, okay, it doesn't like, I can't get down in here. Oh. Okay, let's unzoom this. Okay, hold on here just a minute. Okay, I'm running out of room because I've got too many reasons, too many givens. Okay, let me come over here and we're going to do a, excuse me. Okay, hold on. I'm almost done. Let's do given, reason. Okay, let's do 1 and 5 and then 3 and 7. 3 is equal to angle 7 because those angles are obtuse. Obtuse angles. So therefore, angle 3 plus angle 5 equals 180 because we have an acute plus obtuse angle equals 180. I don't know. That's a long proof, but that's how I would do it. Okay? That's how we do a proof. We have to give reasons why we think that angle 3 and angle 5 are going to add up to be 180. All right. Okay, a segment or a line that intersects another segment at 90 degrees. So notice right here in our diagram, right here in our picture, we've got a 90 degrees. And cuts it in half is called a perpendicular bisector. Bi meaning two, into two equal pieces. Okay? And how do you create that? You have a line that cuts it in half and is 90 degrees. Right there is our 90 degree marking. Okay? All right. What is PN and what is MN? Okay, so we look in our diagram here, and we've got this triangle, and we have this perpendicular bisector. We know it's perpendicular because of this 90 degrees right here. So it cuts it in half. So if this side is a distance of, it states 3, then this side also has to be a distance of what? 3. So NP or PN segment PN is 3. Okay, on our triangle right here, if this side is 7 on MO, then MN also has to be what? 7. So we say MN is 7. Okay, that's how a perpendicular bisector works. All right, okay, we've talked about parallel lines and a transversal cutting right here. Okay, so you get these types of angles, also consecutive, interior, and supplementary. Okay, so it says in the figure, angle 2 is 75. So we're going to call this right here 75 degrees. Okay, so let's use what we know. Well, the angle straight across is a vertical angle, angle 4. It has to be what? 75 degrees. Okay, now this is a straight line angle. We have an acute and an obtuse. So how am I going to figure out how big angle 1 is? Well, this whole angle here is 180. So if you minus 75 from it, you're going to get 105. So the obtuse angle over here is 105. Therefore, number 3, angle 3 also has to be 105. Now, because these are corresponding angles, if this is 105, this also has to be 105. If these two are corresponding angles, this has to be 75. So this is 75 and this is 105. So you're able to find those very quickly. All right. Okay, so now we've got this little problem. So in the figure, the measure of 9, so let's look at 9. 9 is going to be 80. Okay, angle 5 is going to be what, 68? Okay, and find the measure of each angle. All right, okay, now notice these two lines right here are not parallel. It's these two lines that are parallel. So if 9 is 80, let's just kind of do some math here. If 9 is 80, then 11 has to be 80. Okay? And then this is a straight line right here. So this obtuse angle has to be 100. So therefore 12 has to be 100. Okay? All right. Now, if angle 10 is 100, then its corresponding angle number 2 has to be 100. If angle 9 is 80, its corresponding angle here, number 1, has to be 80. Okay, so 3's got to be 80 because of vertical angles, and number 4 has to be 100. Okay, now let's work this line right here. 5 is 68, 7 has to be 68. Okay, that means 13's got to be 68 and 15's got to be 68. Okay, now this is your straight line. So what's 180 minus 68? So I can get that figured out. This will be a 7, this will be 112. Okay, so this is 112. This is 112 because of corresponding angles. Number 8, because of vertical angles, this is 112. Corresponding angles, 112. All right, so angle 12. How big is angle 12 in our picture? It's 100. Okay, angle 1, 80 degrees. Okay, angle 4, 100 degrees. D, we've got angle 3. Angle 3 is 80 degrees. Kind of lazy there, got to get the degree mark. Okay, number 7 is 68 degrees. And 16 is going to be 112 degrees. Okay, pretty simple if you know, understand the vocabulary and how the angles work. Okay, find the value of the variables, explain your reasoning. Okay, so I'm looking at this figure. I got a lot going on here. I got 2 parallel lines cut by this transversal, and also this is a transversal. But I'm going to use my little rule, 180 right here. So I can say 2x plus 90 is 180. So I can solve for x. So these two combined together will give me 3x plus 90 is 180. And I am now running out of room. So I'm going to go over here. I'm going to minus 90 and minus 90. So I'm going to get 3x is 90. Divide by 3, and that is, there we go. We get x is 30. Okay, so this angle right here, so if I've got 1 at 2x, okay, so we're going to do 2 times 30, we're going to get 60. Okay, so this angle here is 60. And then we have 1 with x is 30. This one is 30. We can get rid of this right here. Okay. All right, now I can use my straight line again right there. So let's do this one. 2y. Oh, that's a y and a z. Plus z is 180. Okay, but notice my variables are not like, so I've got to do something different. All right. So think about this. These two lines are parallel. These signs right here mean that they're parallel. So if we know x is 30, what do we know about this right here? Well, this has to be 30. So we can say 2y is 30 degrees. So divide by 2, y is 15. So there's one of them. So if this is 30 right here, how big does z have to be? Well, you can do 180 minus, and this angle is 30 here. That gives you 150. So z is 150. This big obtuse angle over here is 150. Okay? Hope that helps. All right. All right, so this is an assignment that you can work with your teacher and work on your own. And it's kind of a puzzle. Just make sure you do this first, do this second, Third, follow the arrows as you go along. Okay? All right. And I hope that this will help with your assignment.